Hello and welcome to part 3 of the chapter on recursion. I hope you have watched the previous parts of this series. If not, you can always check out, the links are given in the description. So today's topic of discussion will be binary search using recursion. So in class 11 we have already discussed about linear search, but linear search has certain disadvantages. That's why we will be switching over to binary search. So this is the curriculum for the chapter recursion. So this is the last topic of the chapter recursion, which is binary search. So what is binary search? It is a search technique in arrays or lists in which the array must already be in a sorted order. So what is it? It is a search technique. Search technique means, so here you can see there are some list of elements. This 10, 12, 14, 21, 23, 28. What are all these? These are some list of elements. The list of elements of the same type are known as arrays. Okay, so arrays are nothing but list, but it has elements of the same type. Means if there is a list which needs to be called as an array, then all the elements of the list must be of the same data type. Like if they are integers, they should be, all the elements should be integers. If they are floats, then all the elements should be floating point numbers only. So the main condition for binary search is that whatever list or array we are taking, it must already be in a sorted order. Sorted order means it must either be in ascending order or it must either be in descending order. Here we'll basically be concerned about the ascending order. For descending order, it is also basically same. You just have to do a little bit of change in the code. So here, is this a sorted order list of elements? Yes, it is a sorted order list of elements because the elements are arranged in ascending order. So here these are the items, the ones at the top, and these are the indexes. As you know, in case of list, every element has an index. The index starts from 0 to n minus 1. So what is the lower limit of the index? It is 0. What is the upper limit? It is 11. That means it has how many elements? It has 12 elements. That means the length of this particular list is 12. So here binary search can be applied. Why binary search can be applied? Because it is already in a sorted order. But let's consider another list. This is also a list which has index from 0 to n minus 1. But is it in sorted order? Let us check it. It has 18, then 45, it is fine, then 40. That means it is not in a sorted order. As it is not in a sorted order, we cannot apply binary search here. So remember, the condition for binary search is that the list where we are going to apply binary search, it should be a sorted order. Next, so we'll have an algorithm for binary search. So this is the algorithm for binary search. If I just read out the codes, then you will not be able to understand it. I'll explain you this code with the help of an example. So let's say we have a list. So this is our list. So out of this list, in this list there are different elements. So out of all the elements, we need to search for 44. So as a human being, we can just look at the list and we can say that 44 is there at the 9th position. But a computer is not a human being. So it will need to apply some search technique to search for the element 44. Now we are dealing with the search technique of binary search. So let's see how a binary search works. So each and every list has a name. So let's say the name of this particular list is test. Here these are the items, the ones at the top and the ones at the bottom. These are the indexes. As you know that each element in a list has an index. So now this is the lower limit, which is denoted by L. What is the index of the lower limit? The index of the lower limit is 0, and this 11, it is the upper limit. The index is 11. So upper limit means the last element of the list, lower limit means the first element of the list. So here what we can say, the lower limit is 0 and the upper limit is 11. After that, what we need to do, we need to find out the mid element or the middle element. So by binary, by means what? By means 2. So we'll divide the entire list into 2 parts. So for dividing it into 2 parts, we need to divide it somewhere at the middle. So how to find out the middle element? We will find out the middle element with the help of this formula. What is the formula? Int lower limit plus upper limit divided by 2. What is our lower limit? It is 0. What is our upper limit? It is 11. So we'll give int 0 plus 11 by 2. Why this int has been given within bracket? It is given so that even if we get some floating point value, it is automatically converted into int. Why do we need to convert it into int? Because these indexes are nothing but integers only. So 0 plus 11 by 2 means 11 by 2 will get the answer as 5.5. But as we have done a typecasting here, typecasting means forcefully we have converted it into a different data element which is integer here. So we'll get the result of mid as 5. So here what you can see, which is the mid element? 5 is the middle element. So at first, after noting down the lower limit and upper limit, we need to find out the middle element, which is the summation of a lower limit and upper limit divided by 2. Let's move on. After that, we need to check the element at the middle. So what is the element? What is the name of this list? The name of this list is test. So test mid, that means the element at mid. So test 5. So what is the index of the middle element? The index of the middle element is 5. So test 5 is how much? 28. Test 5 indicates the value at the index 5. What is the value of at the index 5? It is 28. So at first we'll take out the value at the middle position. After that we will compare that value with the item to be searched. What is the item to be searched? The item to be searched is 44. So see, we find that 28 is less than 44. So as 28 is less than 44, that means we will need to exclude all the elements which are to the left of mid, including mid. Understood? That means our element will be towards the right hand side. So what will be done here? So now we will take a different list. We will break up the entire list into 2 parts. How? We will now change the lower limit to mid plus 1. What is the value of mid? Mid is 5. 5 plus 1 is how much? 5 plus 1 is 6. So what will happen here? The elements from indexes 0 to 5 will be excluded. And now we will again research only these elements. Okay, so in one stroke only half of the elements can be cancelled. But had you used linear search, we have to check each and every index. Therefore, binary search is very much useful. Let's move on. So now we'll get a new list where the lower limit has changed now because we have done a lower limit equals to mid plus 1. Mid was 5. 5 plus 1 is 6. So we'll get a new lower limit which is 6, but the upper limit has not yet changed. Upper limit is how much? 11. Now we will repeat the steps which I have shown you just now. So now what is lower limit? Lower limit is 6. What is the upper limit? Upper limit is your 11. Now what we need to do? We need to find out the middle element again, which is int. What is lower limit? 6. Upper limit is 11. Int 6 plus 11 by 2, which is 17 by 2, which will result in 8.5. As we have done a typecasting here, it has been forcefully converted into 8. So now the middle element is how much? The middle element is the 8th element. So the middle element position will change from the 5th position to the 8th position. Got it? So now what we will do? We will compare the middle element with the element to be searched. What is the value of the middle element? The value of the middle element, that means at the 8th position, is 42. But 42 is less than 44. So what we will do? We will exclude this part. So we need to search towards the right hand side. Let's continue. So we'll exclude this part. The parts from indexes 6 to 8 will be excluded. Okay, now we are left only with searching of 3 elements. So at first from 12 elements we were left with 6 elements, then from 6 elements in the next stroke we are left with only 3 elements. Therefore it is a very efficient technique. So now what we will have to do? We need to change the lower limit again because we need to search to the right hand side of mid. So now how we will find out the lower limit? By the same formula which we used in the previous step. Lower limit equals to mid plus 1. What is mid? Mid is 8, 8 plus 1 is 9. So what will be done here? The lower limit will shift its position from the 6th position to the 9th position. So now what is lower limit? Lower limit is 9 and upper limit is 11. Now again we need to repeat the steps, so we need to find out the mid element. Mid element is lower limit plus upper limit by 2, that is 9 plus 11 by 2, that is 20 by 2, which will result in 10. So what is the mid element now? The mid element now is 10. So now we'll compare the data of the middle element. What is stored at the index 10? 49 is stored at the index 10. Now we'll compare that element with the element to be searched. Now 49 is greater than 44. That means we need to search to the left hand side of the middle element. So what will happen here? Now we will change the upper limit. So upper limit will be how much? Mid minus 1. So what will happen here? We will need to exclude these two elements, and we are left with only how much element? One element. So now lower limit is 9 and upper limit was mid minus 1, mid was 10, 10 minus 1 is 9. So we'll get the lower limit and upper limit as equal. So from there we'll again find out the mid. 9 plus 9, because upper limit and lower limit both are 9. 9 plus 9 by 2, which is how much? Which is 9. So we'll compare the data at mid. So upon comparing the data at mid, what we will find? Test 9, because mid is 9, we have how much? 44, and 44 was the element to be searched. So our search is what? Our search is successful and the element is found at the position mid. Mid means the current position of mid. What is the current position of mid? 9 is the current position of mid. This is how a binary search works. I'm repeating again, the entire list is divided into two parts in each iteration, means in each part of the loop. After that, based on whether it will be towards the left hand side or towards the right hand side of the middle element, we change the lower limit or the upper limit. Now let us see the algorithm for binary search in English language. So the item to be searched is compared with the middle element of the segment, which I have already explained just now. Whatever item is to be searched, we always compare that element to the middle element of the segment. After that, what we do, if the item to be searched is more than the middle element, the later part of the segment becomes the new segment to be scanned. That means if the item to be searched is greater than the middle element, we will ignore the left hand side elements towards the mid and we will take only the later part. That means we will take only the part which is towards the right hand side of mid. And next, if the item to be searched is less than the middle element, what will happen? We will take only the former part. We will take only the elements which are towards the left hand side and ignore all the elements which are towards the right hand side. The same process then will repeat the same process for each of the segments. The same process is repeated for the new segments until either the item is found or the segment is reduced to a single element and still the item is not found. So sometimes you might want to search such an element which is not present in the list. So then what will happen? The entire list will be searched by using binary search technique, and when it will be reduced to a single element and the item to be searched is not the single element also, then we can conclude that the element is not present in the list. Now let us go to the program code of recursive binary search. We'll now apply binary search with the help of recursion. So for that, so this is the function df. So here, where does the function ends? Function ends in the 12th line. So it will come to the 13th line. What will come here? ls is the variable. Eval input. Eval function is a function which is used to receive a list as an input from the user. So eval input, enter the list of elements in ascending order. So what we need to do? We need to enter certain list of elements. So let's take an example. I'll take the example which I have taken here. 9, 13, 45, 70, 78. So what are the elements? 9, 13, 45, 70, 78. Let's consider these elements. So here next enter item to search. Let's say from these list of elements we need to search for the item of 70. Now as this is a list, each item will have its index, so it's a 0, 1, 2, 3, 4. After that come to the next line. Here function calling is happening. BS is the name of the function. BS stands for binary search. LS is the variable which is receiving all the list of elements. Then item is the item to be searched. 0 is the index lower limit, and length of ls minus 1. What is the length of this particular list? 1, 2, 3, 4, 5. There are 5 elements, but we are doing minus 1 to the length. Why we are doing minus 1? Because here the upper limit should be 4, but we have 5 elements, so 5 minus 1 is how much? 4. So what are the things that are being sent through this particular line of function calling? The entire list has been sent, the item to be searched, that is 70, has been sent, 0 has been sent, and 4 has been sent. So taking these values, the function will come to which line? Function will come to the first line. So here ls will be the entire list, key is the item to be searched, which is 70, l is your 0, and u is your how much? U is your 4. After that, what is being done? Come to the second line. If lower limit greater than upper limit. So what is lower limit? 0. 0 greater than 4? No, 0 is not greater than 4. So we'll ignore the second and third line, and we'll come to the fourth line, where we'll calculate the mid element. Mid equals to int lower limit plus upper limit by 2. So mid equals to int, what is lower limit? Lower limit is 0, upper limit is 4. 0 plus 4 is how much? 4 by 2. That means we'll get 2 as the middle element. So what is the value of mid? The value of mid is your 2. After that, what we have in the fifth line, if key equals to ls mid. So what is the key here? The key here is 70. Key means the item to be searched, equals to ls mid. What is the value of mid? 2. What is stored at 2? 45 is stored at 2. So is 45 equals to 70? No, 45 is not equals to 70. So it will come to the which line? It will come to the seventh line. Elif key less than ls mid. What is the value of key now? Key is 70. 70 less than ls mid. Mid is 2. So what is present at 2? 45. 70 is less than 45? No, 70 is not less than 45. So the 8th and 9th line will be ignored. So 10th line will be executed. So now L equals to mid plus 1. What is mid? Mid is your how much? Mid is 2. 2 plus 1 is 3. So now our lower limit has changed to how much? 3. Since the lower limit has changed, so previously lower limit was this, upper limit was this. But now lower limit has been changed from 0 to how much? 3. So now 3 has become the lower limit. So these 3 elements are cancelled. Okay. So then again the function calling is happening here. That means binary search function has been called with the list, the key, lower limit and upper limit. Now the value of lower limit will change. It will not be 0. It will be how much? It will be 3. But upper limit will remain same. That means upper limit will be 4 as usual. Okay. So now lower limit is 3 and upper limit is how much? Upper limit is your 4. So here we need to do the binary search again. So here if lower limit greater than upper limit, lower limit is 3, 3 greater than 4, no, it is false. So it will come to the fourth line, it will calculate the mid, which is 4 plus 3 by 2. 4 plus 3 is how much? 7 by 2, that is 3.5. But here int is there, so we'll take how much? 3. So now 3 is what? 3 is also the middle element. Now if key equals to ls mid, what is key? Key is the item to be searched, which is 70 equals to ls. Ls means the list. Ls mid. What is mid now? Mid is 3. So 70 equals to what is stored at the position 3? 70 is stored at the position 3. So is 70 equals to 70? Yes, 70 is equals to 70. So what will be returned? Return mid. So this value will come to that line which has called it. Which line has called it? The 15th line has called it. So it will come to the 15th line, and what will be stored at index? The value, that is 3, will be stored at index. Why 3? Because 3 has been returned by the 6th line. After that, now what will happen? So index has 3. If index greater than equals to 0, what is the value of index now? 3. 3 is greater than equals to 0. Is it true or false? It is true. So it will come to the 17th line. What is written at the 17th line? Item found at location index. So what will be the your output, final output? Item. What is item? The value stored at item. Item was how much? 70. 70 found at location index. What is the value of index? 3. So you will get the answer as 70 found at location 3. So is 70 stored at 3? Yes. 0, 1, 2, 3. So this is how a binary search works. So if we run it, you will get this as your output. Okay, but if some value is not there, let's say we'll just take another input here. That's the same code which I have just executed. Let's say now I'll take the value as 2, 7, 14. Okay, so ls means these three values. We have the indexes 0, 1 and 2. Enter item to search. Let's say I want to search for 99. Okay, but do you see 99 here? No. How it will be interpreted by the binary search algorithm? Let's check here. So index equals to bs, all these strings will be carried. You already know what are all these strings. The list will be carried, the item to be searched, that is 99, will be carried, index 0, and length of the list. What is the length of the list? 3. 3 minus 1 means 2 will be carried. So here ls means the list, key means the item to be searched, which is 99, l means lower limit 0, u means upper limit, which is 2. If lower limit greater than upper limit, what is lower limit? Lower limit is 0, 0 greater than 2. Is it true or false? It is false. So we'll come to the fourth line. In the fourth line, what we have? We need to find out the middle element. Mid equals to int, lower limit plus upper limit by 2. That means 0 plus 2 by 2. That means 2 by 2 will get the answer as 1. So what is the value of mid? The value of mid is 1. So now if key equals to ls mid, so what is the value of key now? The value of key means the item to be searched. 99 equals to ls mid. Ls mid means ls1. So 99 equals to ls1. What is stored at ls1? 7. So is 99 equals to 7? No, 99 is not equal to 7. Therefore the sixth line will be ignored and it will come to the seventh line. If key less than ls mid, what is key? Key is your 99 less than ls mid. What is the stored at the mid position? 7. Is 7 greater than 99? 7 is not greater than 99. Therefore it will come to the else part. So here what is being written? L equals to mid plus 1. What is mid? Mid means 1. 1 plus 1 is 2. So what is lower limit now? Lower limit is now, so previously this was the lower limit, this was the upper limit, but now lower limit has become how much? 2. Therefore upper limit is also 2 and lower limit is also 2. That means these two elements will not be searched. That means these two elements has been ignored now. So now again the binary search function will be called return bs ls comma key comma lower limit comma upper limit. So ls means the list, key is now also 99, lower limit is how much now? Lower limit is 2, and upper limit is how much now? Upper limit is also 2. So both lower limit and upper limit are same now. After that, come to the second line. What is written there? If lower limit greater than upper limit, what is lower limit? 2. What is upper limit? 2. Is 2 greater than 2? 2 is not greater than 2. As 2 is not greater than 2, then what will happen? This line will be ignored. So now lower limit is 2 and upper limit is 2. So this line will be ignored and again the middle element will be found. That means what will happen? 2 plus 2 by 2 will again get 2. After that again binary search will come here. So now again 2 greater than 2 it will be searched. This time it will become false. So what value will be returned? -1 will be returned. Okay, so as -1 will be returned, -1 will be carried to line number how much? It will be carried to the line number 15. At line number 15, what will be stored at index? -1 will be stored at index. So as -1 will be your stored at index, therefore what will happen? Now this 16th line will execute. Is if index greater than equals to 0. What is the value of index? -1. Is -1 greater than equals to 0? No, -1 is not greater than 0. So it will come to the else part, which is item not found. So what you will get at the final output? You will get item not found at the final output. So let's take this as the element. If we take this as the element, here 99 is not present, enter the element to be searched. So finally we'll get the answer as item not found. Let's try to run the code related to binary search. So this is the code which I have explained you just now regarding binary search. So if we run it, so it will ask for the list of elements in ascending order. You can give the list of elements. Let's say I'll give 7, then 10. It should be in a sorted order. So we are taking the ascending order. 10, let's say 15, let's say we'll take 34. Enter the item to be searched. Let's say I'm searching for 15. So I'm getting the answer as 15 found at location 2. Is it present at 2? Yes, 0, 1, 2. At the second position, it is there. Okay, we are taking with respect to the indexes only. So now let's run it again. This time let's say I'll give 2 elements, 6 and 9. Enter the element to be searched. Let's say 12. I'm giving enter key. So we are getting item not found because here we have only 6 and 9 as the element, but 12 is not present. Therefore we are getting the answer as item not found. Now let's go back to our slides. So this was our code. Here also we have base cases and recursive cases. Which are the base cases? Return equals to -1 in case of element not found. This is the base case. In case of element found, return mid is the base case. So these two are the base cases. And which are the recursive cases? Where the function calling is happening again and again. So BS is the recursive case. So now if I run the output for element found, I'll get the output as follows. For this set of inputs, you can of course choose different set of inputs as I've already shown while running the code. And if you run the output for element not found, then let's say these are the elements and you want to search for 99, then you will get the answer as item not found. Okay, I hope this is clear. And we are now done with our chapter. So let's just revise it, which part has been done where. So these parts which has been highlighted by red has been done in the part 1 of this particular chapter. You can always go and check out, the link are given in the description. Then factorial, Fibonacci series and also power of a number, it has been done in part 2 of this series. And finally in this part we have discussed about the binary search. So this completes our chapter on recursion. I hope you liked the session. Thank you very much.